Today we are starting our next class. Next class is interpolation. Uh, our next class is interpolation and extrapolation. So first I am discussing what is interpolation. Suppose we have a function y equals to fx, and this function is known for n plus 1 distinct values of x, say x0, x1, x2, x3 up to xn. There is no other information available about the function. That is, the only information we have is f of xj equals to yj, j equals to 0, 1, 2 up to n. The problem of interpolation is to compute the values of fx, at least approximation, for an argument, say x, not found in the table. That is, for an argument other than x0, x1, x2, x3 up to xn. The term interpolation is used when x lies between the smallest and greatest of the interpolating points x0, x1, x2 up to xn, and the term extrapolation is used when x lies slightly outside of the range of the interpolating point. That means if we are choosing one example, suppose x and fx given. X is 0, 1, 2, 3, fx is 3, 15, 19, 31. Set of values are given. So we have to find out, suppose f of 0.5. So this point is not given. Value of this point f of 0.5 is not given in the table. This is inside the range. Our range is 0 to 3. So within that range 0.5 is there. So for this reason, here we can use interpolation. That is interpolation. We can find the value of 0.5 from this table, and if we have to find out f of 3.5, that is our outside of the range, then we are using extrapolation. That is the case. Next, Newton's forward interpolation formula. So what is the formula? Formula is that let a function y equals to fx is known for n plus 1 distinct equispaced arguments, namely x0, x1, x2, x3, xr minus 1, xr, xr plus 1 up to xn, such that we can write xi equals to x0 plus I equals to 0, 1, 2 up to n. We know it. When we are discussing Newton's divided difference formula, we discussed all these things, where h is the length of each space and the corresponding entries are y0 equals to f of x0, y1 equals to f of x1, y2 equals to f of x2, yr minus 1 equals to f of xr minus 1, yr equals to f of xr, yr plus 1 equals to f of xr plus 1, yn equals to f of xn, f of xj equals to yj, j0, 1, 2 up to n. So we have that values x0, x1, x2 up to xn, and corresponding values y0, y1, y2 up to yn all are given here. Then we have to remember this xi equals to x0 plus ih and yj equals to f of xj, j from 0 to n, here also I from 0 to n. Now our objective is to find a polynomial phi x of degree less than or equals to n, which is that phi x simple in nature and which replaces fx on the set of interpolating points xj. Interpolating points are xj, j from 0, 1 to up to n, that means x0, x1, x2 up to xn. These are the interpolating points. So what we can write, phi of xj equals to f of xj equals to yj, j from 0, 1 up to n. So here thing is that we have to find out that polynomial phi x of degree less than or equals to n, which is simple in nature and which replaces fx on the set of interpolating points. Now, so here our fx is a polynomial of degree n, and we assume our phi x as this. Phi x, this is our assumption, a0 plus a1 x minus x0 plus a2 x minus x0 into x minus x1 plus a3 x minus x0 x minus x1 up to x minus x2 an x minus x0 x minus x1 x minus x2 up to x minus xn minus 1 this. The constants aj, j from 0, 1, 2 up to n are to be determined successively by using 1. What is 1? 1 is previous one. Phi of xj equals to f of xj equals to yj. From here we can find that unknown constants a1, a2 up to an. For this reason, this is our this polynomial. As I'm assuming polynomial is equation number 2 and previous condition is equation number 1. And what we are doing, we are substituting x by x0, x1, x2 up to xn successively, and using 1 we get phi of xj equals to f of x0, phi of x0 equals to f of x0, that means y0, that equals to a0. We know na phi of xj equals to f of xj equals to yj. These values are given. J from 0, 1, 2 up to n. Now put j equals to 0. J equals to 0. So first is x0, phi of x0 equals to y0. So that means f of x0. So if we are putting this 0, so what is our this? This equals to a0. Similarly, if we are putting j equals to 1, that means x equals to x1, what we are getting in equation number 2? Phi of x1 equals to a0 plus a1 x1 minus x0 plus, if we are putting next a2, x is x1, so x1 minus x0, this is x1 minus x1 0. So if we are putting all the terms, all will be 0. What is our phi x1 from here? If we put j equals to 1, so phi x1 equals to y1, a0 equals to y0 plus a1 x1 minus x0. That means difference between two consecutive values of x, that is h here. So we can write y1 minus y0 equals to a1 h. So a1 equals to y1 minus y0 divided by h. That means delta y0 by h. That is our a1. Similarly, if we put x equals to x2 in equation number 2, we are getting this x equals to x2. So that is a0, a1, x2 minus x0 plus a2, x2 minus x0 into x2 minus x1 rest, all will be 0. Then we are putting the values of a0, a1. We have to find out a2. So after calculation, a2 is del square y0 by 2 factorial h square. And successively continue this process. We are getting successively a3 del q y0 by 3 factorial h cube, a4 del to the power 4 y0 4 factorial h to the power 4, a5 del to the power 5 y0 by 5 factorial h to the power 5 up to an del to the power n y0 divided by n factorial h to the power n. Now we are getting all the constants. Now we are putting all the constants in this here in this polynomial. Then what we are getting? I am showing you. So we are, after putting these values, we are getting this polynomial phi x equals to y0 plus delta y0 by h x minus x0 plus del square y0 by 2 factorial h square x minus x0 x minus x1 plus del cube y0 by 3 factorial h cube x minus x0 x minus x1 x minus x2 up to del to the power n y0 divided by n factorial h to the power n x minus x0 x minus x1 x minus x2 up to x minus xn minus 1. So this formula for interpolation is known as Newton's forward interpolation formula. But when we are solving some problems, this formula is not so easy to handle. For this reason, we are using some transformation to uh, make it uh, useful for calculation. For this reason, here we are using the transformation x equals to x0 plus uh. For this reason, we are using this transformation x equals to x0 plus where u is the new variable. So this is written as x equals to x0 plus u equals to x minus x0 by h. Similarly, x minus x1 is x is x0 plus x1 is x0 plus h. So if we simplify it, we are getting u minus 1 into h, x minus x2, x is x0 plus that is the transformation. X2 we know that x0 plus 2h, that will be u minus 2 into h. Similarly, x minus xn minus 1 is u minus n minus 1 into h. Now we are putting all these values here. Then what we are getting? Phi x will be, phi x is equivalent to y0 plus x minus x0 means u delta y0 by h plus x minus x0. X minus x0 is x minus x0. X minus x0 is uh. So this is uh. X minus x1 is u minus 1 into h, u minus 1 into h into del square y naught divided by 2 factorial h square plus uh u minus 1 into h, u minus 2 into h del cube y naught divided by 3 factorial h cube. Similarly, what we are doing? We are writing uh u minus 1 into h, u minus 2 into h, u minus n minus 1 into h into del to the power n y naught divided by n factorial h to the power n. If we are simplifying it, we are getting y0 plus u into delta y0 plus u into u minus 1 divided by 2 factorial del square y naught plus u into u minus 1 u minus 2 divided by 3 factorial into del cube y naught plus u into u minus 1 u minus 2 up to u minus n minus 1 divided by n factorial h to the power n. So this is the formula where where u can be written as x minus x0 by h. So this is the procedure. So this is the formula we discussed here. Already we proved this formula. How to find this formula? We generate it. Next we are having some notes. If x lies between x and x naught, then x naught is taken as starting point. If x lies between x1 and x2, then x1 is taken as starting point. If u equals to x minus x0 by h, this is dimensionless and u lies between 0 and 1. Now there is a problem. We have to find out the value of f of 3.5 from the following table. This table is given below. This is the values of x, this is the values of y. So 3, 4, 5, 6, 7, 8, this is values of y. After that, first what we are doing, we are writing this difference table. X is these values 3, 4, 5, 7, 8 and values of y these values. After that we are finding the first order differences, that means differences between these two: 37, 125 minus 64, 61, 216 minus 125, 91, 343 minus 216, 127, 512 minus 343, that is 159, and these two differences 61 minus 37 24, 91 minus 61 30, 127, 127 minus 91 that is 60, 36, 169 minus 127 that is 42, and their difference is 666. So first this is the difference table. Now we have to find out 3.5. So 3.5 lies front side of the table. Since 3.5 is the point which lies beginning of the table, so we are using Newton's forward interpolation formula, and 3.3 lies between the interval 3 and 5. Hence, here we take x equals to 3.5. So x0 equals to 3 and h equals to 1. Therefore, we calculate u equals to x minus x0 by h. So then this is 0.5. Now the formula is this. This is the formula already we discussed. So here 3.5. So y0 is x0 is 3. So y0 is 27. Del y0 is 37. Del square y0 is 24. Del cube is 6. Rest will be vanished. After calculating, we are getting this value. So if we have this Newton's forward difference formula, so forward interpolation formula, we can easily find the values. Next, we can find the value of f of 1.3 from this following table. Same thing, 1.3 is here, lies between 1 and 2. For this reason, what we are doing? First, we are forming this difference table, same procedure 0, 1, 2, 3, 4, 1, 1.5, 2.2, 3.1, 4.2 like this. Then we are using first order difference. Then we are finding second order difference. Then what we are doing? Since 1.3 is the point which lies beginning of the table, so we are using Newton's forward interpolation formula, and this 1.3 lies in between the interval 1 to 2. So what we are doing? X equals to 1.3, therefore x0 equals to 1 and h equals to 1. Therefore u equals to x minus x0 by h. X is 1.3 minus 1 by 1, that is 0.3. So now the formula is this. This is a formula, forward difference formula. Then if this is our, now this is our x0. So y0 1.3, del square y0 0.7, del cube y0 is 0.2. So there is a slight difference from previous one and now. So what we are doing, then after simplifying, we are getting this answer. So this is Newton's forward interpolation formula up to this. Now again I am discussing from the beginning what we are doing here. First I am discussing the definition of forward, definition of interpolation and extrapolation. Next, we are discussing Newton's forward interpolation formula. For this reason, some criteria are needed. So first, I said that criteria, we have a function, all points are equidistant points. For this reason, we are writing xi equals to x0 plus ih. Then we are writing yi equals to f of xi, I from 0 to n. Then we are assuming that interpolating function phi of xj equals to f of xj equals to yj. After that, we are assuming this polynomial. Then we have to find the constants a1, a0, a1, a2 up to all these. Then we are substituting these values and we are finding these constants successively. Then we are finding this formula. Then we are using this substitution. With the help of this substitution, our formula is easy to handle. We are getting lastly this formula, and with the help of this formula, we are solving some problems. This is the first problem. I am discussing how to solve this, and there is another one. So we have to solve this formula now up to this. In the next day class, we will discuss Newton's backward interpolation formula up to this.